Beneath the landscapes of Switzerland and France, a chilling development is unfolding at CERN. Esteemed physicist Roger Penrose has sounded an alarm, suggesting that recent experiments with the Large Hadron Collider have triggered something terrifying and evil. What exactly is stirring in the depths of CERN's massive underground facility? What could this mean for our understanding of the universe? Join us as we dive into the mysterious events at CERN and uncover the potential implications of these shocking occurrences. Understanding CERN, the European Organization for Nuclear Research, is one of the world's largest centers for scientific research in particle physics, located near Geneva on the border of Switzerland and France. It operates the famous Large Hadron Collider, LHC, the biggest particle accelerator in the world. The main purpose of CERN is to explore the fundamental elements of the universe, the building blocks that make up everything around us. By studying these particles, scientists at CERN hope to understand the forces that hold them together and thus gain deeper insights into the laws of nature. Recently, Roger Penrose uncovered that something extremely shocking and evil happened at CERN that no one can explain. But what does CERN do in the first place? At its core, particle physics examines how particles interact with one another and the dynamics of these interactions. The Large Hadron Collider, CERN's flagship project, plays a crucial role in this research. It accelerates particles to nearly the speed of light and then collides them together. These collisions produce a burst of new particles which are observed and recorded by detectors. Analyzing these particles helps scientists answer questions about the basic principles of physics, like the interactions that occur within a proton and the forces that operate at the smallest scales. CERN contributes significantly to technological advancements and practical applications that benefit society. The scope of its research and influence extends far beyond the confines of its laboratories, affecting various aspects of modern life and knowledge. CERN is renowned for its remarkable contributions to technology, which have significantly impacted the world beyond theoretical science. Among its most notable innovations is the World Wide Web. The World Wide Web was developed in 1989 by British scientist Tim Berners-Lee while working at CERN. Berners-Lee created it as a way to enable scientists around the globe to share information effortlessly. This invention revolutionized how we access and disseminate information, paving the way for the internet-driven world we live in today. The first website ever was hosted on a computer at CERN, marking the start of the digital information age. Beyond the digital world, CERN's technological advances have also made significant strides in medical technology, particularly in the field of medical imaging. Technologies developed for detecting particles in CERN's experiments have been adapted to improve medical imaging techniques. One such adaptation is the use of particle detection methods in positron emission tomography scans. This application has enhanced the ability of healthcare professionals to diagnose and treat diseases such as various forms of cancer more effectively. Moreover, CERN has contributed to advancements in radiation therapy, another critical area in the treatment of cancer. The precise technology used in particle acceleration and manipulation at CERN has been utilized to develop new methods of delivering radiation therapy which are more accurate and less harmful to patients. These innovations mean that radiation can be administered in a way that maximizes its effectiveness against tumors, while minimizing exposure to surrounding healthy tissues. The influence of CERN's technological innovations extends even further into other sectors. For example, the superconducting magnets and vacuum technologies developed for the Large Hadron Collider have applications in sectors such as aerospace and manufacturing, where materials capable of performing under extreme conditions are crucial. So while CERN's primary mission may be centered around particle physics, its contributions to technology show a huge and far-reaching impact on our daily lives. From the internet to healthcare, the technologies developed at CERN have gone beyond their original scientific purposes, becoming integral parts of various industries and helping to solve real-world problems. Roger Penrose's concerns. So who exactly is Roger Penrose and what shocking secret did he reveal about CERN? Roger Penrose, a celebrated figure in the world of physics, has made massive contributions that have significantly advanced our understanding of the universe, particularly in the area of black holes and space phenomena. His work earned him the Nobel Prize in Physics and also deeply influenced the field of theoretical physics. Penrose's journey into space began with his groundbreaking theory about black holes. In collaboration with Stephen Hawking, he developed the Penrose-Hawking singularity theorems. These theorems provided mathematical evidence for the existence of singularities, which are points in space where gravitational forces cause matter to have infinite density. This work was pivotal in confirming some of the predictions of Albert Einstein's general theory of relativity, particularly regarding the behavior of black holes and the origin of the universe immediately following the Big Bang. Another significant aspect of Penrose's work is his proposal of the concept known as conformal cyclic cosmology. This theory suggests that the universe iterates through infinite cycles, with each cycle beginning with a Big Bang and ending in a smooth and uniform state. This innovative idea offers a radical perspective on the universe's possible eternal nature, challenging the conventional understanding of the universe's temporal progression. Penrose has also delved into the complex relationship between physics and consciousness. His orchestrated objective reduction theory, developed with anesthesiologist Stuart Hameroff, proposes that quantum processes are integral to the functioning of the human mind. This theory bridges the gap between understanding the physical processes of the brain and the mysterious nature of consciousness. In addition to his theoretical advancements, Penrose's contributions to mathematics are not to be overlooked. He invented the Penrose tiling, a non-periodic tiling pattern that never repeats exactly, which has been influential in both mathematics and art, illustrating the potential for aperiodic patterns in natural structures. Roger Penrose's work has expanded our grasp of black holes and the broader universe. It has also paved the way for further scientific inquiries into the very foundations of reality, intertwining the immense forces of the universe with the intricacies of the human mind. His theories continue to inspire and challenge both established and aspiring scientists in the field of physics and beyond. Roger Penrose has recently expressed concerns regarding potentially alarming developments at CERN. His warning refers to recent experiments conducted at the Large Hadron Collider that might have unexpected and, according to Penrose, possibly sinister implications. The Large Hadron Collider is the world's largest and most powerful particle accelerator located at CERN. It was built by the European Organization for Nuclear Research between 1998 and 2008. With the aim of allowing physicists to test the predictions of different theories of particle physics and high-energy physics. This is crucial for advancing our understanding of the fundamental components of the universe. The Large Hadron Collider is a massive circular tunnel, about 27 kilometers in circumference, buried approximately 100 meters underground. It straddles the border between Switzerland and France. This giant ring is equipped with a series of superconducting magnets and a number of accelerating structures to boost the energy of the particles along the way. The main purpose of the Large Hadron Collider is to explore the physics of the smallest particles. By colliding particles at close to the speed of light, the LHC allows scientists to observe processes that give clues about how the particles interact and provide insights into the fundamental laws of nature. One of the most famous discoveries made using the LHC is the Higgs boson in 2012, which helped confirm the standard model of particle physics. This is the theory describing three of the four known fundamental forces: the electromagnetic, weak and strong interactions, and classifying all known subatomic particles. In simple terms, the Large Hadron Collider works by accelerating two high-energy particle beams in opposite directions around its ring. These beams are made to collide at various points along the loop. The collisions create new particles, which are detected by sensors and recorded for further analysis. The particles are accelerated using a strong electric field, while powerful magnets steer and focus the beams. The main challenge here is the engineering required to keep these particles moving in a tightly controlled beam at speeds close to that of light. Superconducting electromagnets, which are cooled to minus 271.3 degrees Celsius, which is colder than outer space, are crucial for this task because they can conduct electricity without resistance, creating stable, high-powered magnetic fields. Given the extreme conditions and energies involved, safety is a paramount concern at the collider. Numerous safety systems are in place to monitor everything from radiation levels to the integrity of the equipment. The design and protocols ensure that any particle collisions and their aftermath are contained safely within the facility. Scientifically, the Large Hadron Collider has been a monumental success, enabling significant advances in physics. It has tested various theories that were previously unverifiable. For example, besides discovering the Higgs boson, the Large Hadron Collider has provided valuable insights into the quark-gluon plasma, a state of matter that existed shortly after the Big Bang. The Large Hadron Collider is a key tool in the field of particle physics, pushing the boundaries of human knowledge about the universe. Its ability to simulate the conditions just moments after the Big Bang opens up unprecedented opportunities to explore the origins and makeup of our universe. But there is something evil going on that scientists at CERN cannot explain. Penrose has hinted that the nature of these experiments and their results could pose unseen dangers, which have not been fully explained or understood even by the experts at CERN. While specific details of these concerns were not fully disclosed, the term evil used by Penrose suggests a level of severity that warrants public attention and scrutiny. The context of Penrose's warning centres around the fundamental and highly experimental research being conducted at CERN, particularly in the world of particle physics. The LHC is designed to uncover the basic building blocks of the universe. Such experiments push the boundaries of known physics and could potentially lead to discoveries that challenge our current understanding of the natural world. The nature of these experiments is inherently risky, given that they involve manipulating fundamental forces and particles at extremely high energies. The idea of evil associated with these scientific endeavours might be metaphorical, implying the possibility of unintended consequences that could arise from tampering with the unknown. It raises ethical and existential questions about the extent to which humanity should pursue knowledge, especially when the outcomes are uncertain and potentially harmful. The concerns expressed by a scientist of Roger Penrose's stature suggest that the recent activities at CERN might have far-reaching implications, not only for the field of physics but also for our broader understanding of reality and existence. His warning calls for a more cautious approach to high-energy particle physics research, emphasizing the need for thorough consideration of potential risks and the unknowns associated with such groundbreaking scientific work. Therefore, it is crucial to investigate further to understand precisely what has happened at CERN, the potential dangers involved, and how the scientific community plans to address these concerns raised by one of its most respected members. This is the latest news from CERN and its shocking discovery. Until next time.